Greetings to everybody. Here we're looking at interpenetration, a section which is found on question 1, whether you are in grade 11 or grade 12. Whatever we find in question 1 is regarded as to be in first angle orthographic projection, unless otherwise is stated so. Now looking at what we have here, we have two prisms which are meant to fit together and fit around. So we have this top view here and we have that as a front view. These two will be given to you on the question. However, the third view is what you as a learner will need to project, is what you as a learner will need to determine. Now, why is it that I need to have that view? The points which I'm going to talk about are easily seen on this view which we have obtained. They are not easily seen on the top view, neither on the front view. Therefore, it is important that you draw the third view so that these points are labeled easily. By the way, all these points that you see that I have labeled here in pen come from that view. So without this view, it's not easy for you to label these numbers over there. Okay, therefore, what are these points called? Number 1, we have what we call an end point, or if you like, is also known as termination point. These points, we see it as when we have 1, 2, or 3. Let us look at the front view. I've got 2 there, I've got 1 here, I've got 3 here. Let us look at the right view. Number 1, number 2, and number 3. Remember, this is the base of this branch solid that will be given to you. That is a triangular base of the branch solid. So 1, 2, 3 are known to be an end point. If you like, it's also known as termination point. That is why if you look at number 1, project it to the top view, 1 end point there, and that's the end point there. 2 and 3 likewise, same as number 1. Now project these to the front view. That's why you see that there's number 3, that's point 1, that's point 2. Now I need to find something here which is known as line of interpenetration. Now I also have A and B, and I label A and B as turning points. Why is it that A, B are known to be a turning point? If we look at the square prism itself on the top view, we'll realize that if we start from W, we're going at a 45-degree angle to X. Then it turns, or it changes its direction on X. It goes to point Y. From Y, it turns or changes it to another direction. It goes to Z. Likewise from Z to W. So these corners, W, X, Y, Z, are known to be turning points. However, in this question here, we are not worried about W, Z, or Y, because X is what we need to worry about, since our branch solid is fixed or is fitting on that side of the point or of the prism. Therefore, we shall be looking at this point only as a turning point. That is why you will realize that on the right view, I've labeled A turning point on line X and also on B Now, take note that I have nothing here as a turning point on the front view, neither I have it over there. So how then do we label this? You could have started anywhere, 1, 2, 3. It doesn't matter how you label it, as long as it is labeled. And when you want to interpret it later on, it's easy for you to understand it. Therefore, having 1, 2, 3, back to 1, or 1, 2, to me, it makes it very simple. So what we then need to do is, we need to find these points by projecting vertical and horizontal. Those are the two things that you need to remember. We are doing number 1, our endpoint vertical, meaning that it comes from the top view. Then we do number 1 horizontal when it's coming from the right view. When these 2 points intersect, that is the line of intersection. Then we are finding those points. We will then quickly do that. So let us start with number 1. Number 1, vertical. Since I've already projected those horizontally when I was finding this point, then it becomes easier. So this will be number 1 immediately. Now we need to find 2 and 3. Remember, 2 and 3 both on the same position. That's 3, and this is number 2. So I put there number 2, I put there as number 3. All right. So what does it mean then? I have done the end points because I only have 3 end points. Now what about the turning points? Turning points, B is on line X, and this is line X. So it means I have already projected vertically. Now I need to project horizontally. So what I will do then, I will need to project from B, it goes to X. This is point B. From A, it goes to line X. So this is A. Now, we have done all these points, turning points and end points. Now, what we need to look at, we need to look at the right view as to how do we go around this branch solid. From 1, we need to go back to number 1. So what does it read here? How does it read here? It says 1, A, 2, 3, B, 1. So from 1, you need to stop at A. From A, you need to go to number 2. Stop there. From 2, you have to move to number 3. Stop there. From number 3, go to B. Take a break. Stop there. From B, you go back to number 1. That's how we need to join. We're going to look at this front view here using this right view in order to complete our curve of interpenetration or line of interpenetration. Then I say, let us join this. From 1, we go to A. Remember, everything still needs to be light at the moment. 1 goes to A. From A, where do we go to? We go to number 2. From 2, we go to number 3. Remember, this is 2 to 3. From 2, we go to number 3. Light. From 3, we go to B. From 3, we go to B. From B, we go back to 1. Then we go back to 1. Now, all this construction is now complete. Now that we have an idea of our curve of interpenetration, how it's going to look like, now we need to determine what we see and what we cannot see. This is the direction which we are facing. So, in order for us to get that view, this is where we are standing. Remember the rule of first angle orthographic projection. What you see from the left is drawn on the right. What you see from the right is drawn on the left. In this case, this is our direction which we are facing. It then says we can see 1A, 1B. Can we see B to 3? The answer is no. Can we see A to 2? The answer is no. Can we see number 3? The answer is no. Now, let us verify what we say here on the top view. If we say we only see 1A, 1B, why is it that we're not seeing anything beyond X? Now, this is what simply means. If I'm standing at this position again, that's the position which we're looking at. It means, looking up, I will see Y to X. That's correct. But anything above X that goes that way, I will not be able to see. So it means 1A I will see and 1B I will see. But I will not be able to see from X or from A to number 3 and from A or from B to number 2. I will not be able to see that. So it corresponds with what I'm saying on the right view and what I say on the top view. I will see 1 to 1, the end point, definitely. So once you have determined that, it then means make or draw dark what you see. Then you need to study again or determine the points which you cannot see. We agree that from 1 to 1 in that direction you will see. Therefore, this will be now drawn dark. That's 1. Then we said from 1 to A we see. From 1 to B we see. Yes. Then let's make it dark then. 1B, we've already discussed that. We can see this. And 1A, we can also see that. Now, that's done. Then we say, from B to 3, we cannot see. From A to 2, we cannot see. Therefore, from 2 to 3, we cannot see. That is becoming hidden detail. So since I've made construction lines, I'm just going to erase a little bit so that when I draw my hidden details, it is much more clearer that it's a hidden detail line. We're saying from A to 2, we cannot see. From A to 2, we cannot see. Therefore, that becomes hidden detail. And then we say from 3 to 2 also, we cannot see that. From 3 to 2, we cannot see that. And we're saying from 3 to B, we cannot see that. From 3 to B, we cannot see that. Therefore, these are our hidden details thus far. And we said, if we're looking at that direction, can we see 2 to number 2? The answer is no, and the answer is yes. Now, why is the answer saying no and why is it saying yes? Because if you look at X, if you place a set square on X and you're looking up, it means where X is, we can see everything on the right hand side, but we cannot see anything on the left hand side of X. If I move the t-square away, then I'm saying anything on the right hand side of X we see, but anything on the left hand side of X we cannot see. So this is where I'm talking about. From this position of X to number 2, we cannot see. From the position of X to number 3, we cannot see. But we can see from 2 to that position. We can see from 3 to that position. Because this is where we're standing. So why X is blocking everything on the left hand side of X. Therefore, which is why I then say from 3 to this position is now drawn dark. From 2 to the position of x is now drawn dark. Correct. Therefore, from position of x moving towards 2 and moving towards 3 is hidden detail, because we agree that we cannot see that. Okay, so this then becomes hidden detail. That then becomes hidden detail. Now, few things that you need to complete. Same position on the right view. This is where you're looking at. So we will see x to b. We will see x to a from that position. Definitely. Therefore, on the front view, we're saying from x to b, we shall see. We're saying from a to x, we shall see. And this is your answer in terms of what you see. And then we have hidden details over there. Therefore, this a to b is hidden detail. Therefore, likewise here, from a coming to b will be hidden detail. Now, this is what we call interpenetration. Now, we have found the curve or the line of interpenetration. This is, or it applies to grade 11 or grade 12. Thank you.